Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is account cyclic paths. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you never miss out an update. Let's get started with the problem. The problem statement says that given a triangular pyramid uh, with its vertices marked as 0, A, B, C, you can see here, and a number n. The task is to find the number of ways such that a person starting from the origin O initially reaches back to origin in n steps. Okay, so it's going to be a cyclic path. In a single step, a person can go to any of its adjacent vertices. Okay, so like from this O, he can go to either C, B, or A. Similarly, from this A, he can go to either O, B, or C. From this B, he has three options, and similarly from this C, he has three options. Okay, so now we have to tell how many cyclic paths are there in n steps. So let me take, for example, n is equal to 1. So if I start from 0, I have this pyramid. I will have this pyramid. Okay, so O, A, B, and C. So what we can do is, from this O we can move here, here, or here, but we have n is equal to 1. So if I move to A, B, or any point C, then will not end to O. So this is not going to be a cyclic path, so that's why I'm going to return 0 as my output. Now let me take one more example, that is n is equal to 2. Okay, so I have two steps. So what I can do is I can go from O to any other point and return to O. So what I can do, I can go from O to A and then return to O. Similarly for this, I can go to B and return to O, and I can go to C and return to O. So there are three possible paths. There is no other path that I can see here, so the output is going to be 3 in this case. I hope you got the clear understanding of the problem, what the problem exactly is, and let me just move to the solution now. So the solution that I can see here, what I can do is from any point I can take 3 steps to any two other points. So like it's going to be a recursive approach, kind of recursive approach, and let me just explain you the approach. So initially I'm going to have n as my number of steps, and I will have the current position like over here, and let me just take n is equal to 2, and from n I have three options from O. I can either move to A with n minus 1 steps, or I can move to B with n minus 1 steps, or I can move to C with n minus 1 steps. Similarly, from this A, what I can do is I can move to either B with n minus 1 steps, or I can move to n minus 2 steps. I can move to C with n minus 2 steps, or I can move to O. Also now from this I can move to either A with n minus 1 2 with n minus 1 2 steps, and or I can move to C with n minus 2 steps, or I can move to O with n minus 2 steps. Okay, so now let's see for this place. From C we can move to either A or B or O, isn't it? I will have n minus 2 steps here, and n minus 2 steps here, and I will have n minus 2 steps here. Now for this my n was 2, for this my n was 1, and for this my n is 0. Now when our n becomes 0, then we have to check the path which are ending at O. So like this path is ending at O, this path is ending at O, and this path is ending at O. So if I see, so this path is nothing but O, A, and O. Similarly, this path is O, B, and O. So O, B and O is going to be another path, and O, C and O is going to be the third path. And the total number of paths that we got is 3. So this is going to be our output. So what we can do is, from any point n, we have option to move any other point. So let me just code this approach. I hope you got the understanding what we are going to do. So what we can have is, we will have a function that will take n and the current position as input. Now let me just implement this function. I'm going to make it long because it's saying that for larger values you have to return mod 10 raised to the power 9. Okay, so I will have and current position as a character. Okay, so I'm even going to have a variable that is my mod. Okay, so now let me just code this. If my n is equal to 0, then I'm going to return position equal to O or no. If my current position is O, then I'm going to return 1, else I'm going to return 0. Also, now I will check for my position, what my current position is. If my current position is O, then I can go for A with n minus 1 steps, or I can go for B with n minus 1 step, or I can go for C with n minus 1 steps. Else if my position is equal to, let me make it positions. If my position is equal to A, then I'm going to return B with n minus 1 steps, or I can go to C with n minus 1 steps, or I can go to O with n minus 1 steps. Similarly, for my position can be B as well, and for my position to be B, I can go to A, C or O. Else my position will surely be C, and from C we can go to A, B or O. So this is going to be the recursive approach, and let me just code it, check whether it works or not. So okay, it's showing it is going to be a long, so I'm going to return it somewhere. And even I'm going to calculate the mod, and let me just return this as an integer. So let's see whether it works or not. It's working for the example test case, and let me submit it. So it is going to throw time limit exceed error for larger values. Okay, so what else we can do? We can have a DP array. So we can use the memoization technique here, and we are going to have an integer, actually a long type of DP array. Okay, so my DP array will look like my DP array will be something like what we can do here. We can have plus 1, and we are going to have a 4. So now let me just show you what 4 represents. So actually I'm representing 0 with A, and 0 with O with 0, and A with 1, and B with 2, and C with 3, because we cannot store the character as an index. So I'm even going to calculate my position. So what is going to be my position? My position is going to be, actually what is going to be my index? Sorry, I'm writing a position. So my index will be decided by my position. So if my current position is O, then my index is 0, else if my current position is A, then my index is going to be 1, else if my position is B, then my index is going to be 2, else Okay, so now I'm going to store the output in my TP array. So I will do this, and let me paste it here as well. Okay, so and one more condition that I have to write, which is the main condition. So if my TP is not having null value, then I have to return TP. So this is the step which performs the actual memoization. Let's see whether it works or not. So it's showing the compilation error. Why? Because I'm writing semicolon here. Okay, position. Let's see. Okay, it's working for example test case, and let me just submit it. Okay, so I'm not using the mod operator here. I have to write mod in order to avoid the overflow. Here as well. Okay, so let me just take it as my sample input, and let's see whether it works or not. Okay, it's working, and let me just submit it. Okay, I think it should work, but okay, so for larger values, it is doing stack overflow error. So what we can do is we can have another approach that is going to be tabulation approach, and let me just write the tabulation approach here. So I've already copied that approach, and I'm just going to paste it because even that approach is going to show me time limit exceed. So just in order to show you, I have written that approach. So this is the tabulation approach, and let me just run it. Even this approach is not going to work for all the test cases. I have just written this approach in order to show you. Okay, so it is also showing time limit exceed, and let me just write another approach that is even going to remove the use of this space as well, which extra space which is being used by this TP array. So actually I have shown you the recursive approach and all the approaches in order to show you the intuition behind the solution that I'm going to write. So I will have a previous A. Okay, so let me just explain you before writing this approach from this tabulation that each time or the answer of current iteration, that is I, is dependent on the just previous one iteration. So why we have this whole array? Instead, what we can do is we can store the previous value in a variable. So that's how we are going to remove this space as well. So let me just start writing here. I will have a previous of O will be equal to 1. Why? Because our current position for the initial iteration is O. So this is similar to this test case, and let me just write previous of A is going to be 0 and previous of B is also going to be 0. Similarly, previous C is going to be 0. So I have written this condition. Let me just make this as long. Okay, so now I can remove this. Now what I'm going to do is I'm going to calculate my current O as previous A plus previous B plus previous C and mod. Similarly, I can calculate my current A. So actually the current A represents the path to go to A from the by taking one more step. So the total number of paths that we will have plus previous of C plus previous of O and mod. After that, I'm going to have my current B as I will have my current B as previous of C plus previous of A plus previous of O, and So where I can move from C, I can move to either O, or I can move to like A, or I can move to just B. So now I'm going to change my previous values. Like now the number of paths to reach O is going to be my current O. Similarly, number path to reach A is going to be my A. Similarly for B and C as well. Now my total path will be equal to, what I will do is I will just return previous of O. So this is what we are doing in this approach. I'm even going to explain it at the end. Let me just submit it. So let me tell you what exactly I'm doing here. Okay, so it's working, and this is all about this problem, and let me just show you what I'm doing. So each time, or if I want to get the number part to come to O, so from this to come to this O, we have to we can come from either A or B or C. So that's why I'm adding the possibilities from all these places. Similarly for this A, we can come to A from either B or C or O. We cannot come to from A to A, like we are not making any move here. Similarly for this B, we are coming from this C and A or O. So that's what I'm doing here. So this is all about this problem. I hope you like the solution. If you like the solution, subscribe the channel and also like the video. So this is all about the video. Stay tuned. Thank you.